Today we're having a look at adding and subtracting surds. First thing to consider here, for us to add and subtract surds, we need to have what we call now in the same way that 2x plus 3x is equal to 5x, 3x is equal to 5x plus 3y can't be simplified any further. 2 root 2 plus 3 root 2 plus 3 root 2 because those are the same base, they can be simplified. They can be put together. They can be put together. 2 lots of something. If I have 2 lots, 3 lots of something, plus 3 lots of something, means I have 5 lots. But if I have 2x plus 3x, 2x plus 3x, like me having root 2 plus root 3 plus root 3, there's nothing I can do with that. That's not equal to root 5. That's not equal to root 5. I don't just go and add together my bases in the same way that I couldn't say x, y, or a little bit of x, y, or a little bit of x, I can't deal with that. I can't deal with that. So to add together my surds, I must have the same base. So root a plus root a would be root a plus root a would be 2 root a. Okay. But root a plus root b, they can't go together. That's just root a. So these laws, these rules for adding and subtracting surds are very similar to adding and subtracting algebraic terms, very similar set of laws. Now another thing to recall here, say for example, I'm adding together root 2 plus root 8 plus root 8. Well, as far as I see it there, we have nothing not equal to root 10. That's not equal to root 10. That's what this symbol here means, by the way, not equal to. But what is it we could possibly do here? If we think back to our previous lessons, we can recall that I can do something with this 2 root 8. So I can turn this root 8. So I can turn this root 8. I can look at that and say, well, 8 is 4 times 2. 8 is 4 times 2. 4 times 2. Same as root 4 times 2. Which is root 4 times root 2. Root 4 times root 2. By splitting that up. Which is 2 root 2. Okay, and if we think about it, once we've simplified that, this expression is equal to root 2. This expression is equal to root 2 plus 2 root 2, which is I've got one of something. I've got one lot of root 2 plus another 2 lots of root 2 plus another 2 lots of root 2. That's 3 lots of root 2. So that's the type of thing we're going to be dealing with here. Examples here which should about cover us, because these questions do become really repetitive, and the biggest place I can encourage you to look to make these questions easier is to actually go and review your lesson on simplifying surds if you're having trouble with this, because that's probably your biggest concern. The first thing to think about here for our first question, we've got root 5 plus root 5 plus 2 root 5. So if we think of this algebraically, this is the equivalent of me saying I've got x plus 2x. Okay, if root 5 is the same as x, well, I hope you look at that and say I've got 4x, but rather than us saying we've got 4x, I'm going to say I've got 4 root 5. Okay, so we don't have to write it as 4x, of course. In fact, we shouldn't write it as 4x. We should actually not have this line at all, because I haven't written anywhere what x is, what x represents. But that's just a representation to say if I'm adding one of something plus another of something plus 2 more of it, I have 4 of it. Okay, in the same way I would have an apple plus another 2 apples, I'd have 4 apples. Except instead of apples here, we're dealing with root 5s. For our second example, you'll notice we've got a problem. The simple thing to do would be just go, well, I'll go 12 plus 27 minus 3, and I'll put it all under a square root, and that's fine. Again, not quite how we can operate. This is a little bit different to an algebraic question, because if I had 5x plus 3y, well, there's nothing more I can do with that. Okay, I can't go and change x in some way to make it more favorable or make it more a like term than y. But actually with surds, we do have an option to do that. We have an option to go and say, all right, well, I'm going to think about root 12. Okay, well, root 12 I can split up into root 4 times root 3. And my giveaway here is this root 3 at the end. Okay, I'm having a look at that root 3 and thinking, if I can make the root 12 and the root 27 into something root 3, then I've got some like terms I can add together. That's sort of my hint. If you've got a surd that is hanging around somewhere that's got quite a small prime base, like a root 2, a root 3, a root 5, maybe even a root 7, that might be somewhere where you could say, oh, that's something that I could work with in terms of like surds. That's not to say what they always come down to, but that's just always a place to be having a look. My second one, if I think about that, well, I could, again, let's think about what are the factors of 27. 3 9s are 27. That's great because I've got a square number. And again, I've got my root 3. And then I've just got this root 3 hanging at the end, which is a little hint to start with. Well, that means what I've got now, root 4 times root 3 becomes 2 root 3. Root 9 becomes 3 and root 3. And then take away 1 lot of root 3. So I've got 2 plus 3 minus 1 is 4 root 3. Okay. Now, I'm going to show you another step here. This is if I wanted to write this as a single surd. My answer is a single surd. And it's almost like undoing the work we just did in a way. It's putting it, rather than having things as a really simplified surd, it's actually blowing it back up a little bit. So what I'm going to do is I'm going to turn that into, rather than being 4 root 3, I'm going to say that's root 16 times root 3. Now let me just clarify here. This is our best answer. Okay, our simplest answer. But if we wanted to write this as a single surd, or in a way we asked to show that something is equal to this, or maybe this might be useful if we're doing something with a right angled triangle and we're having to square something, this final answer that I'm doing in green might be more useful. But this answer here is our best answer. Okay. If you're asked to simplify a surd, that's where you should stop, unless you're asked to do something otherwise. Now, from my last step here, 16 times 3, I can put that back together and say that's root 48. Okay, so that's how I can write that answer. Now, we did need to know that last step there, which is if I've got root 16 times root 3, it's just a reversal of splitting those surds up. But that is in our next lesson on multiplying and dividing surds. But I can do that once you've watched that lesson. That very last step may make a little bit more sense. Our last one here has got a little bit more to it, but it's just a result of the same thing. I don't have a hint this time, so I don't have a nice small prime number at the end. But once I go and think about what factors I have to work with here, the 2 at the front is just a multiplication of 2. It's just got a coefficient of 2 already. Now I can split that up into root 100 times root 2. Now once I've got my first root 2, I'm thinking the second one's probably going to have a root 2 in it somewhere as well. So I've got the 3 that hangs at the front, and then I've got 49 and 2. So my next line of simplification becomes 2 times 10 times root 2 minus 3 times 7 times root 2, which is 20 root 2 minus 14 root 2, just becomes plain old 6 root 2. To clarify a couple of things here, there's a couple of lines you probably don't need to write. If you don't want to write this line, that's fine. You can leave that one off, but I do think you need the other lines in there. And to get really, really accomplished with these, and you can jump straight from somewhere like that down to this line here, I wouldn't be skipping too many steps there. But you can check with your calculator as well. If you go put 2 root 200 minus 3 root 98 in your calculator, you should get exactly the same thing as 6 root 6 if you put that in your calculator. I hope this has been helpful.